In this example, we're going to focus on finding the intercepts of the graph of an equation without actually graphing that equation. So we're just going to be working with the equation itself and no graphs. So I left some space here between the instructions and the actual example because in these 3 or 4 lines here, we're going to write in the strategy for solving this type of problem. So again, we want to find the x-intercept or intercepts and the y-intercept or intercepts, if it has multiple ones, of the graph of each of these 2 equations. Also note that it's possible for a graph to not have any x-intercepts or to not have any y-intercepts. Okay, so recall from the graph, the coordinate system, that intercepts are where the graph intersect either one of the axes, either the x-axis or the y-axis. And any point that is present on the x-axis, if you were to plot any point along here, would have coordinates of an x value and definitely a y value, but in order to be on the x-axis, you'd have to have a y value of 0. Similarly, if you were to plot a point directly on the y-axis, this point would definitely have an x-coordinate and a y-coordinate, and it could be at any y height, but in order to be directly on the y-axis, it would have to have an x-coordinate of 0. So this is a really important observation to make about intercepts, and that is directly how we solve this problem. So in order to find an x-intercept, we note that y has to be 0. So when you're working with an equation instead of the visual graph, what you want to do is substitute y equals 0 into the equation. Once you've replaced y with 0, all you're going to do is solve for x to find the value of this x-coordinate. So it's basically just 2 steps, and then to find the y-coordinate, you're going to do exactly the same thing, except you're actually trying to find the y value. So in order to find a y-intercept, we know that x has to be 0. So you'll repeat those same 2 steps, except you'll replace x with 0 and solve for y. Okay, so we are going to use this strategy right here on 2 different equations for extra practice. So I want to find both x and y intercepts. I will pick one to start. Let's go ahead and find y intercepts. Okay, and in order to find y intercepts, we're going to substitute 0 for x and then solve for y. Okay, so here is my equation right here, y equals x squared minus 1. I'm going to replace x with 0 and solve for y. I like to find y-intercepts first because typically they're easier. So 0 squared is 0, minus 1 is negative 1. Since I only found one answer, this graph only has one y-intercept, and that occurs at negative 1. Okay, now let's find the x-intercepts. Similar strategy, but this time I want to know what x is, so I'll substitute 0 for y and then solve for x. So same equation, 0 in for y, x squared minus 1 on the right hand side. So x squared minus 1 is a beautiful difference of squares, and it's equal to 0. So I'm going to factor that right-hand side. You could also use a quadratic equation, knowing that this is a quadratic, and that would work just fine as well. Okay, so I have a product equal to 0, so I'm going to use a zero product rule and set each of those factors equal to 0, and then solve. So since I'm finding two answers, two viable solutions, that means this graph has two x-intercepts. So it's very possible for a graph to have several intercepts, only one of each kind, or absolutely none. Okay, so let's take a look at this second example. The equation is 5x plus 2y equals 10. I'm just going to follow the exact same strategy. So let's go ahead and find the y-intercepts first. So again, since I'm looking for y, x has to be 0. So we'll substitute 0 for x and solve for y. So up here, 5 times 0 plus 2y equals 10. We know 5 times 0 is 0, so 2y equals 10. Divide both sides by 2. Y equals 5. Again, since I only found one viable answer, this graph only has one y-intercept, and that occurs at 5. Now let's find the x-intercepts. We'll replace y with 0 and solve for x. And my equation is 5x plus 2y equals 10, so I have 5x plus 2 times 0 equals 10. 2 times 0 is 0, so I really have 5x equals 10. Divide both sides by 5. X equals 2. Since I only found one answer, this graph only has one x-intercept.